Hi students, myself Tanmoy Dotto, Assistant Professor, Department of Chemistry, JS College of Engineering, Kolani. Welcome you all in my third lecture of water pollution. You know, water pollution is included in the module 3 of environmental science. Today we will discuss about the hardness and the alkalinity of the water. That means how many types of hardness, which ions are responsible for the hardness, or how we can remove the hardness, what problems arise from the hardness. That means from the point of view of domestic life or from the point of view of industrial purpose. Today we will discuss all these things, and also we will discuss the alkalinity of the water sample. So let's start the class.
First of all, we will discuss about the sources of water. You know, there are mainly 4 types of sources of the water. So first source is the surface water. Surface water means which water present in the surface, like a river, lake, wetland, etc., etc. Surface water is naturally produced by the precipitation, and naturally it is lost through the discharge to the oceans. Then second, that under a river flow. So there is another source of water. This is the under a river flow. And the third source of water is that groundwater. Okay, so all of you know very well that groundwater is the fresh water. Okay, fresh water located in the surface pore or space of the soil and rocks. It is also water that is flowing within aquifers below the water. So groundwater is another important source of water, and generally it is taken as it is a pure water, and we use that we used for our drinking purpose. Okay, now the third category is that fourth category is that frozen water. Okay, frozen water is also very fresh water. Several schemes have been proposed to make use of iceberg as a water source. You know that if there is any question like that, which is the more pure water, like your the rainwater, groundwater, and pond water, whatever, and the water of glaciers, then the option will be water in the glaciers, because the frozen water is the most pure water till now. This water is the not polluted. Okay, so that's why the frozen water is the most pure water, and that's why there are several kinds of proposals are there to make use of iceberg as a water source. However, to date, this has only done for a research purpose. Okay, glacier runoff is considered to be the surface of water. The Himalayas, which are often called the roof of the world, contain some of the most extensive and rough high altitude area on earth, as well as the greatest area of glaciers. Okay, so in this way, the frozen water is the another source of water. Till now it is not used, but it can be used. Okay, even from that point of view, it is the source of water. So that means there are actually 4 kind of sources of water present. First of all, surface water. Second, under river flow. Third, groundwater, and the fourth one is the frozen water. Now come to the point that water quality parameters. You know, there are several water quality parameters are there, starting from acidity, alkalinity, biological oxygen demand, which we will discuss in the next class, chemical oxygen demand, conductivity, dissolved oxygen, hardness, metal, organic nitrogen, or the nitrogen ammonia, phosphorus, pH, total dissolved solid, temperature, turbidity. So look there are 14 types of water quality parameters. Okay, so there is actually some kinds of purposes that in which we are using the water. Depending on our purpose, we can check the water quality purpose. That means it is not required that for each and every cases we have to check the 4 water quality parameters. Where it is required or for which purpose we are using the water, depending on this fact, we have to check the water quality parameters. Okay, so now think about that specification for drinking water, BIS and the WHO standards. If you think about this factor, then look here that there will be color. Okay, so there will be odor, there will be taste, there will be pH, there will be BOD, COD, their total alkalinity. Okay, in this way there is some label. Okay, so maximum permissible limit specified by the WHO. Okay, so this will be in this way that there are some values which we have to take according to the WHO. Then the calcium, maybe some permissible limit, magnesium, then copper, then iron, then arsenic, lead, mercury, cadmium. All these are some kinds of values are there. Okay, there are some values by which we can determine, we can understand that what is the permissible limit for the drinking water. Okay, so nitrate, pesticides are there, E. coli, etc. etc. There's all the parameters we have to check for the drinking water. Now come to the point that classification on the water based on its behavior towards the soap. This is the most important point of today's class. Okay, on the behavior towards the soap. That means there are two kinds of water. First one is the soft water, second one is the hard water. Okay, so soft water means water which easily forms lather with soap is called the soft water. That means soft water means that which can easily form the foam with water very rapidly. This water is called the soft water. But what is the hard water? Hard water means water which does not easily form lather or foam with soap is called the hard water. This is the general way. That means visually how we can understand which is the soft water and which is the hard water. This is the method by which visually we can understand the soft water and the hard water. Now hardness of the water. The hardness, if you think about the hardness of the water, the special properties imparted in water due to presence of dissolved salts of special type, say bicarbonate, sulfate, chloride of calcium, magnesium and iron. There is an interesting case, keep in mind, that generally we take that what are the reasons behind the hardness of water. Generally we take it as the some salts of the calcium and magnesium, but actually not only calcium and magnesium, there are some contributions also for the iron. Okay, so calcium, magnesium and iron, that three ions are responsible. Calcium, magnesium and iron, that three ions are responsible mainly for the hardness of the water. You have to keep in mind this fact. Okay, these three ions are responsible, not only calcium, not only magnesium, but majorly we take that calcium, some salts of the calcium and magnesiums are mainly responsible for the hardness of the water. And which salts? Bicarbonate, sulfate, chloride, carbonate, etc. etc. Now cause of the hardness, that hardness in water is caused by the presence of a multivalent cation. Okay, multivalent cation means cation where valency are greater than 1. So normally you know this is the calcium 2 plus and the magnesium 2 plus. For example, the presence of calcium 2 plus and magnesium 2 plus impart hardness to the water. These ions are incorporated into water in the form of their soluble salts. That means calcium and magnesium ions are present in the water in the form of the soluble salts. Okay. Now you know that calcium and magnesium ions, what I told you, that generally iron is not considered in this case, but calcium and magnesium ions of salts of calcium and magnesium are mainly responsible for this type of hardness. But which ions, which salts are responsible, depending on that, which anions are responsible, depending on this fact, we can classify the hardness of water in these two way. So first one is the temporary hardness and second one is the permanent hardness. Okay, so from the name I think it is very much clear that what is the temporary hardness. So temporary hardness means, what is the meaning of temporary hardness? Temporary hardness means, look here, that it is the hardness of water due to presence of a bicarbonate salt. keep in mind that it is the hardness due to presence of bicarbonate salt of metal having valency greater than 1, that means calcium and magnesium. Okay, so temporary hardness only due to bicarbonate ions. Okay, bicarbonate ions of the cations like calcium and magnesium. So this is called the temporary hardness. So why temporary, I will explain later, that it can be, you can remove it very simply boiling. Okay, so you can remove it very simply by boiling. So like it is a calcium bicarbonate. Okay, so only bicarbonate ion, then either calcium bicarbonate or magnesium bicarbonate, these two salts are mainly responsible for the temporary hardness. So if you give some heat, that means if you apply some temperature, then what happen, then by heating you can remove the hardness. How? Because calcium carbonate will be precipitated out. Okay, calcium carbonate or magnesium carbonate here. So these two salts will be precipitated out if you if you give the heat, okay, by simply boiling. Okay, then what water you are getting, this is the fresh water, that means this water will be soft water. Okay, so in this way you can remove very easily the temporary hardness, and that's why, and for this reason actually it is called the temporary hardness. So you have to keep in mind that what ions are responsible for the temporary hardness. Okay, that means bicarbonate ion is mainly responsible for the temporary hardness. And why it is called the temporary hardness? Temporary hardness is called because we can remove this kind of hardness very easily means by simply boiling. Okay, so if we remove this kind of hardness by simply boiling, then how is it possible? Because calcium carbonate and magnesium carbonate, these two salts can be precipitated out if you boil the temporary hard water. Okay, now come to the point of what is the permanent hardness. So permanent hardness is due to the presence of the salts other than bicarbonate. Okay, other than bicarbonate, all other salts if present in the water, it is called the permanent hardness. Okay, so permanent hardness of metals having valence, obviously calcium, magnesium, whatever, then it may be chloride, it may be sulfate, it may be carbonate, etc, etc. So these two things, these things are actually responsible for the permanent or for permanent hardness, or for this reason actually permanent hardness we can expect. Okay, so permanent hardness you can't remove in the simple way like the temporary hardness. That means for the permanent hardness we should take some kinds of special procedure by which we will be able to remove the permanent hardness. How is it possible to remove the permanent hardness? Okay, I'll show you that for the very common process of removing the permanent hardness is it is the permutate process. Okay, so now first of all you have to know what is the permutate. You know, in this process actually, or what is the permutate process? In this process, the artificial zeolite is known as commonly here used in this process. That means in permutate process generally artificial zeolite is used. Okay, and you know artificial zeolite known as the permutate. Okay, and it is commonly used. Now the general formula of the permutate is Na2O Al2O3 X SiO2 Y H2O, where X equal to it, the value of the X may vary from either X equal to 5 to 13 or Y equal to 3 to 4. Okay, so in permutate process, first of all you have to know in this process what is the meaning of the permutate. This is another important question. You may expect this type of question in the MCQ question, or in the short type of question where you have to write down the formula of the permutate, or what is the common name of the permutate. So the common name of the permutate is zeolite. It is actually zeolite, and the formula will be Na2O Al2O3 X SiO2 YH2O, where the value of X and Y vary from either 5 to 13 or 3 to 4. Now they are insoluble in water. Okay, so this permutate, they are generally they are insoluble in water, but can exchange Na plus for higher valent cations like calcium 2 plus or magnesium 2 plus. That means generally permutate is the insoluble in water, but it can exchange Na plus Na plus for higher valent cation. Okay, calcium 2 plus and magnesium 2 plus. Now come to the point that what is the permutate process, or how we can remove the permanent hardness by the permutate process. So in this process, look here that when hard water is allowed to percolate through a bed of permutate, okay, that means there will be a bed of permutate through where we have to pass the water. Okay, Na plus in the permutate, because Na plus, you know that in the formula they are already available. Na plus is available, okay, in the formula. Look here. So this Na plus in the permutate are replaced by Ca2 plus and Mg2 plus, okay, present in the hard water. But equivalent amount of Na plus goes into the water. Okay, so equivalent amount of Na plus will mixed with the water, but Na plus does not impart hardness, so water becomes soft. You have to keep in mind that in this process actually Na plus replace the calcium 2 plus or magnesium 2 plus ion. So what water we are getting, or what water will get after removing the permanent hardness, this water will contain the sodium ion. Okay, if you check the reaction, then it will be more clear. Then what happen actually in this process, Na plus, if Na plus remain in the water, there will be no problem, because Na plus will not give or will not impart any kind of hardness. So that's why there will be no such kind of problem arise regarding the hardness. Now if you look the reaction, then what happened? If you check the reaction, then Na2Z, okay, plus calcium salt. Okay, Na2Z means here it is the permutate. Overall formula is not required here, that's why here it is written Na2Z. So Na2Z plus calcium salt, which gives us a CaZ plus Na salt. Okay, so this Na salt actually remains in the water, but it will not give any kind of hardness. In the same way, if there are magnesium salt present, if there any kind of magnesium salt present, then what happen? It will form the MgZ. Okay, so Z will replace to the here, come to here, and Na will form the Na salt. So either their calcium present or their magnesium present, there will be no problem, and Na plus easily it can remove the calcium 2 plus ion or magnesium 2 plus ion, and in this way actually hard water can be so we can convert it to the soft water. So you know that Na2Z stand for sodium zeolite, in which Na part is exchangeable. Okay, what we observed in the reaction, that in Na2Z it is the sodium zeolite, Na plus is replaced by the calcium or magnesium ion. Both temporary and permanent hardness can be removed by this method. That means if the water which we are using, we know that generally temporary hardness we can easily remove by the by boiling the water, but if we pass or if we use the permutate method, then there is not required any kind of further boiling the water. Okay, it is not required. That's why here it is written that if we pass the water through the permuted bed, then automatically both type of hardness, your temporary hardness and permanent hardness, both type of hardness will be removed. Okay, so there will be a time when the permuted bed gets exhausted. Obviously, when all the compounds or all the chemicals will be finished with the reaction, it can be regenerated by using 10% NaCl solution. So keep in mind here the main important ion which takes part in the reaction, this is the Na plus. So that's why there must be Na plus sodium ion present in the permuted bed. If their sodium ion is not present, that means here it will be not applicable for the reaction. So that's why 10% NaCl solution we have to use. Okay, so again, to regenerate when the permuted bed is not suitable for the process, then again we have to charge the permuted bed by the addition of 10% NaCl, and during a regeneration Ca2 plus and Mg2 plus again it will be replaced by the Na plus. Okay, so this is the process by which we can convert the hard water, either temporary or permanent, both type of hard water, to the soft water. Now chlorination of the water, chlorination of the water means in this process chlorine is added to the water to kill certain bacteria and other microbes. Okay, so this is for another reason, that chlorine is used in the water for to kill certain types of bacteria and the microbes. In particular, chlorination is used to prevent the spread of waterborne disease. That's why sometimes in municipal water they are also municipality, in some kinds of municipality they are also used the chlorine in the water. Okay, so because there are some kinds of waterborne disease which we can be removed, of which we can be bacteria can be killed by the by utilization of the chlorine. Okay, so like there are some waterborne diseases like cholera, like typhoid, etc., that can be spread from the water. That's why sometimes we have to use chlorine in the water. So this is called the chlorination of the water. When dissolved in the water, chlorine converts to the equilibrium mixture of chlorine, hypochlorous acid and the hypochloric acid. Okay, that means HOCl and the HCl. So in this way chlorine kill the bacteria or the microbes which may be dangerous for our health, and that's why it is important. But there is no doubt in this process, because chlorine generally it is if it mixed with the drinking water, I think there is some kind of doubt in this process, because it may be harmful for our body. There are some articles also available in this regard that chlorine if we use for the water which we use, even if the chlorine come to touch of our skin. Okay, so this may be harmful. Okay, so that's why this process is very suitable to kill the bacteria and microbes, but how much it is beneficial for the human body, there may be a question mark. Now we'll discuss some question answer. Okay, there are some simple question like what is the first of all what do you mean by alkalinity? Okay, this is the very important question of this topic, or which we have to discuss also. What is the alkalinity? Alkalinity refers to the capability of water to neutralize the acid. Okay, so alkalinity means it refers to the capability of water to neutralize the acid. This is really an expression of the buffering capacity. This word is very important. Okay, alkalinity means generally we can define in one sentence, that is the buffering capacity of the water. Alkali substances in water include hydroxides, carbonates, and bicarbonates. Moderate in this way, actually, alkali substances means in water it includes hydroxides, carbonates, and the bicarbonates. Moderate concentrations of alkalinity are desirable in most water to balance the corrosive effect of the acidity. Okay, so this is also another thing, that moderate alkalinity it is required, because acid generally it become very much corrosive. The acid has some kinds of corrosive effects. Okay, so to balance the water, okay, to maintain a balance of the water, then what we have to do, we have to use some kind of, or there's some kinds of alkalinity also expected. Okay, such that the corrosive nature will be decreased. So generally the unit of the alkalinity, what is the unit of the alkalinity? Unit of alkalinity generally it is the milligram per liter or ppm, obviously with respect to calcium carbonate. That means the alkalinity which is determined generally it is calculated with respect to calcium carbonate, and the unit may be milligram per liter or ppm, the same thing, either milligram per liter or it is the ppm. So now come to the another question. Okay, so first of all, look here, what is the groundwater? We already discussed what is the groundwater. A large amount of water present in the beneath earth surface within the void spaces of soil and rock particles. Formation of this underground water is mainly due to two process. Okay, how this groundwater is actually form. There are two processes, by the sipping of water and the stream water, and direct sipping of the rain water. Okay, so water generally water exists into different zones beneath of the earth surface, under saturated zone or the saturated zone. Okay, so in this way we can classify the, or we can know that formation of the groundwater. So this is the overall syllabus of your water. Previous day we already discussed, in previous class we already discussed your all types of some kinds of parameters of the water, and now today in today's topic the most important thing is the hardness of water, that how it is possible to know about the hardness of water, and then how it is how we can understand that how much or which ions are mainly responsible for the hardness of water. And also there are some kinds of here temporary hardness, here permanent hardness, and how these kinds of hardness are possible to remove. All these things are very important. And generally there is another thing, that permuted process is also very much efficient to remove the temporary hardness and the permanent hardness also. So in this way you have to keep in mind. And alkalinity also another fact, the question may arise in this way, that what is the alkalinity of the water sample. So then you have to write down the definition, that what is the alkalinity, or what is the what ions are responsible for the alkalinity, or little bit alkalinity is also required for to maintain the balance of the water. Okay, so that's all for today, and this is the this is the syllabus for the hardness and alkalinity. And in the next class I will meet with you with different topic, so you have to read all these things. Okay, so take care, goodbye, and thank you for attending my class.